Oh, has he ever? Has he ever?
I don't know what time it is. Oh, it's time? Put you here. Good morning. We'll be starting here in a few minutes. Don't forget to sign the blue sheets. The on-site tool will do that for you. We'll pass this around. So I wish I could. Yes, I'll hang this from my neck and walk around so everybody can scan. Okay, excellent. Yeah. And if one of the people in the back row, I think that's Mr. Sullivan back there, could close those back doors, I think that's a proper use of ISOC president's abilities. Yes. I say that with just the pure love in my heart. Yeah. Thank you, Mr. Sullivan. Yeah. I'm glad I can see you. So welcome to DNSOP. It's Monday morning, and Monday mornings make me really cranky, so I apologize. I think, and we got a bunch of stuff going on. My name is Tim. This is Benno. That's Suzanne. We're the chairs. Warren with the hat is sitting there in the row. He's our ISG person. I'm glad to see him. Next to former ISG Joel, which confused me because they took all his hair away from him when he left the ISG. No hat. So the links are there for the Meet Echo, the on-site tool. Please click the on-site tool button in the data tracker. So you sign up, or you have to sort of find this thing. We'll probably pass this around and do something. Paul Hoffman, who's sitting back there. Thank you, Paul. Like I said, I don't like to assume that you're going to do the minutes, so thanks for doing that for us. Since this is Monday morning, we'll actually sort of walk through the note well a little bit, just letting people know that since you're at the IETF, you're going to follow our processes and policies. You may be recorded. Please, pay attention to all this and just try to be cognizant of what's going on there. Some meeting tips: definitely use the Meet Echo stuff. Make sure you've got all the little bits going on. So the on-site tool seems very good. Meet Echo's gotten, it just gets better and better, sort of thing. And that's where the chat stuff is. We do have a code of conduct. Treat colleagues with respect. Try to speak slowly. I fail at that, so I really have to work on that. You see all this? And we work as individuals, so let's remember to be nice to each other. So, and we all are. I think, one thing DNSOP is good at is actually doing that. So we've got a good 2-hour agenda, some bashing going on. You guys, I appreciate everybody doing the bashing on the email list and beating us up, which is okay. That's what we're here for. We've got an update on some current work. The hackathon updates, the reason I kept wanting to move this meeting from Monday to another day is we usually like to get the hackathon stuff into the DNSOP presentation cycle, and it usually takes us a day or so. But we did get some slides, thanks to Willem, and I stuck them in the meeting materials kind of thing. So, and we may chat a little bit about that. So there's some current business and some stuff for consideration, a lot of consideration. Peter's here to talk about CDS consistency. He got in late last night due to a bunch of flight mess ups. So please be decent to him about that. So we appreciate you pulling it all together, Peter. Schumann's going to talk about his compact denials of existence, which is a much nicer title than what it used to be. So that's a good thing. Bunch of stuff in consideration. Paul's going to talk about the 7598 biz to deal with the key rollover. Mr. Bellis is going to talk about his QD count. The great conversation about QD count is one. One's going to talk about out-of-protocol signaling. Johan's going to talk about the zone pipeline work. Peter again we're going to drag Peter back up to talk about the DNS notifies, and then the multi-algorithm rules for doing DNSSEC. What? Oh, Peter can talk about that as well? So not you. You'd say Peter. Yeah. Yeah, you aren't going to talk about the last one. Oh, the notifies Johan and Peter's. Okay, my bad. So I just got both names on there. I think I was just pulling the first name off of there. So we got some document updates and some Jared's vibes on what's going on. There is a bunch of work going on. So as you all aware, so catalog zones is finally an RFC. Yay, thanks to everybody. Thanks for all the implementers for sort of making that happen. That's a good thing. It's a nice long process. We've got 3 things in the editor queue still. Service B, and thanks for Eric and Warren for kind of getting the RC editor back on track on that cluster. All TLD, Blue is not optional, which will have a better name when it's done. So we did park this document since the last IETF. It went through working group last call. We got some comments, but it was, as we sort of ground through everything, it was one of these things where we couldn't get enough people. People had, suggestions on edits and stuff, but people weren't like, no, this is still stuff that's really useful at this date. So we're just parking it where, we can figure out what to do about it later, sort of thing. But that's okay. So thanks everybody for helping us out with that. And then another park document.
Yeah, I'm offline.
You're offline. So the other park document is 5933biz, which is the GOS stuff. We worked with Warren on talking with the authors. They submitted the GOS protocol to ISE. And then once that goes through that process, they'll clean up 5933biz and resubmit it. So thanks, Warren.
Network problems.
So we broke the internet.
Yeah. Is there an Ethernet cable?
There you go.
Outside Ethereum network.
So the next document, I'm actually pulling this out of memory now, so I apologize. We had a working group last call. I pushed the submit button, and then the next day I pulled it back. This is the caching resolution failures. We feel it's done, but during the hackathon, so we had some conversations about one of the timeout values, a negative caching, and I wrote that up, sent an email, and there's some little discussion last night. What we'd like to see is, I think right now it says 5 seconds, suggested to sort of start at 1, based on some operational experience. And what we need to do is the folks that have that operational experience need to help sort of document that in sort of the appendix, sort of thing. Yep, is that it? Yep. So hang on. Yeah, there we go. Did I catch everything? So yes, I sent some suggested text. We'd like to hit some feedback. And Peter in the DNS directory review did mention having an appendix and some implementation stuff. So the person I chatted with about that Sunday, we'll chat some more and sort of work on something. But I don't think this is going to hold the document up very long. But when we do, we'll probably send it back to the mailing list and get some folks to sort of weigh in on that. So also in working group last call, and so this is where we do have a lot of stuff going. 8499biz, the working group last call closes today on the delegation discussion, and we're going to incorporate the interim info into the Shepherd write-up, and then be done. So push that off. The zone version write-up should wrap up this week. We'd like to move that along. And the error reporting working group last call last week, and the Shepherd write-up is promised to come up after IETF. And I will not, I'm just as guilty, so please. For Vori fragmentation, this was interesting. I was going through the thing, and one thing I suggested to the authors, I wasn't sure if it was a good idea or not, but I numbered all the recommendations for easier reference as we sort of talk about them. And like in section 1, there's all these in section 3.2. I think it's useful. Someone can tell me that was sort of foolish. But Peter brought up a very good point that there's a recommendation that says don't fragment, but none of the implementations actually implement this. So we'd like to hear if anybody, please get up and bash us about this, like what we should do about this. And I'm going to sit down, hopefully with the authors this week, and we'll try to figure out like what can we do there. So that's a very good point. It's like if we recommend something and then nobody implements it, what are we doing? So, and I think that may be the final piece of that puzzle. So domain verification techniques, I use this as my DNS operator test. It's like when I see people get excited about this document, I know they operate large amounts of zones and they care about the data in the zones. And then if you don't, then it's like you do DNS, but it's not the same kind of operator stuff. So that's just me. I get super excited by this. Authors have been working through the comments and really sort of putting up with me hammering them really hard about this. But Eric Nygren's had some really great comments, but they're kind of involved. One about multi-CDN cases, and then another one about binding tokens to requests, kind of a security possibility that I think they're a bit involved to sort of write up. We're trying to get Eric to help us, but he's a busy guy. And so we'll see if we can sort of get some of your time. And I call it the DNS structure review because Mr. Reed was sort of reviewing the older version, but he admits that, and he's going to, work to resolve all that stuff. So thank you all. Did you lose internet again?
Yeah, I did. Okay.
So sad.
Yeah.
So while we're ready for working group last call, I think we've got 2 more documents. I just chatted with Ben and sort of hijacked him and said Service B Dane is getting ready, as well as the DNSSEC bootstrapping. I want to get a couple of the other ones pushed onto Warren's plate. Sorry, Warren. Even though we feel very confident. I know there's a lot of stuff in flight, but we actually feel like we're managing them fairly well. If we're not, please come yell at us, kind of thing.
Yeah, I'm trying to recover, sorry. Yeah.
So probably like,
yeah,
I'm like maybe I'm 2/3 of the way through. So there's a bunch of slides. So yes, thank you, Ben, for putting up with me, hijacking you. And
still not there, sorry.
It's like if we only knew somebody who worked for the NOC.
Yeah.
I'm sorry. I'm just teasing you, Warren. Yeah, we love you. You know that.
I'll try another network.
Yeah.
Previously, there was some.
Suzanne was reminding me, like, it was one of the first meetings she was chairing with me where we lost the internet in the middle of it. And I was like, I don't remember that. It was like, that had to be, more than a year ago,
very good,
basically.
very good.
So
okay, I'm back. Okay.
It's okay. I can
improvise.
run my mouth for a few minutes.
And very well.
Yeah.
12. Here.
Yep.
Okay.
And so, document status stuff. Good. So NS3 validation. We feel all the outstanding issues are resolved. We feel the chairs feel the draft is ready, and we feel it's good as standards track, but we know there's people out there, and you should speak up, that may feel differently about this one. So we want to hear that. And when we do the working group last call, I think that's what we're going to sort of pull out and sort of make people sort of accept that. DNSSEC automation. Schumann had been working for a new author. He found Johan, which is also a bonus because he's implemented the draft. Yay. This is cool. I get excited by implementation stuff, but there's a few tweaks left, and then we're working group last call before the end of the year. I'm going to put you on notice, sir. So structured DNS error. Good presentations at the last meeting, I believe. Was it the last meeting? Or was it OARC? The authors feel it's ready for working group last call, but my vibes are the experiments are still ongoing. It updates the EDE, the extended error document, which is we're just starting to see appear out in the world, right? Like Google just announced they're giving out extended errors and stuff, and that makes me nervous as an implementer. It's like we're going to update, make changes to sort of the registry while people are still sort of playing with this stuff. It does implement 2 new registries, but we feel we need more operational experience and feedback because it's one of these documents. Like I would love to see like the Microsoft servers, the AD servers sort of support this and how they sort of handle it, sort of thing. But the working group can tell us differently. So this is one of those crazy drafts where people do want to deploy it, but it's like one of the weirdest things in the world. But you all tell us that, yes, we're ready for working group last call. We just feel it's, we need to see more stuff going on. So CDS consistency is going to be talked about today. 8109 biz, that's the root priming queries draft. We feel it's ready for working group last call in the fall, probably September-ish kind of thing, which I think will still give the folks plenty of time related to the KSK work. I believe that's what, yep. So combat denial of resistance is on the menu today. And we've got a bunch of stuff that's candidates for adoption, and they're all on today's agenda. Now, one thing Johan pointed out, which we apologize, is the DNS notify was discussed at the last meeting, but I started this conversation about the 2 notify Mr. Levine's and Mr. Johans, and we got a bunch of feedback, and this is my bad because I remember this and now I forgot it. So you can fault me for that, and I will take that blame, sort of thing.
We all do.
Other documents. Mocha's V6 Ops IPv6 only resolver draft that they call for adoption of V6 Ops. They deferred to us as to what we want to do, which I was like, why us? We're just a bunch of crazy DNS people. But since Warren is the AD for both groups, the suggestion was let V6, we feel the work's adoptable. We feel V6 can adopt this, but we will be very willing to hold an interim with V6 Ops on this draft. And Mocha is presenting a V6 Ops tomorrow morning. The other thing that came up is Mark Andrews and I had one of those conversations where we kind of argue each other for like a couple hours, and it's all good. But he did point out that 3901 needs to be updated. And so I started working on the text for that, submitted something into the data tracker. And the chairs, we decided to ask Mocha if she would actually help us actually updating that. That's the V6 operational guidelines for DNS servers, published in 2004 when we were all like, teenagers or something. And so it definitely needs to be updated to talk about dual stack stuff, to talk about IPv4 as a service, et cetera, et cetera. So we will probably bring that to the list and start doing that. I put my name on it, but I'm not going to, of course, force anything on stuff. So, but she seemed very eager to sort of help us with that. So thank you for that. If she's here, I just want to say thank you. So other sessions, we're getting there. I'm almost done. The ACM IETF session this afternoon at 3 o'clock or 3:30. There's a couple DNS things. The DNS integration work with, I believe it's a couple of folks from VeriSign. And then the Query 'em all. Was it Johan? Johan, he was one of the authors on that. Was in the hackathon room with us, and we chatted a bit about stuff, and it was very interesting sort of thing. Of course, the ADD session tomorrow. I think DNS has the on Thursday. It's always something DNS going on. You know that. And the chairs wanted to give a sort of call out for the directorate for helping us out, Jim. So, yay. And we find them useful. We hope the working group finds them useful. We know it feels a little weird to get a directorate review of the DNSOP document, but it also helps the chairs kind of focus what we think is going on. So, and so just remember that. They're just in like all the other input. But we've also been requesting early security reviews because we've noticed as we go through the process, that's the part that gets sort of stuck in the IHG process. Like if we had an early security review on 5933 biz, we could have saved ourselves a lot of pain, right? So we would have saved Warren a lot of pain, which is very important to me. So we find them useful, and we're going to keep doing those, pretty much. If you see one show up for your draft, that kind of means we're thinking we're going to do working group last call on your document in the next few months, kind of thing. So that's kind of helps us where we're going. So, of course, what else are we working on? The data tracker, keep our stuff in GitHub. We do some social stuff using the data tracker API, which I think is very important for these. And I was talking with Mark Saturday during this, and because we do lots of work, HTTP does lots of work. I took Mark's tweet API and hacked it up for Mastodon. But busy working groups should overshare. That's all, and that seems to be a really great sort of way to sort of view why we do this, right? Why we push stuff in GitHub, why we sort of push things out. So we want people to sort of be paying attention in different ways. We want to reach, there's DNS people everywhere. We just want to reach them, sort of thing. So, and I think that's it for me. So did I keep it under 20 minutes? Oh, God.
Nailed it exactly.
Okay. I was going to be in trouble if I didn't. So anyway, I will leave you all. I'll just go back and sit down. But thanks for listening. Come find us, speak up, et cetera, et cetera. Okay, thanks.
Okay. Yeah, thanks. The CDS, this one. Pete? You can use the clicker. Yeah, it will work. Yeah.
Hello.
There you go.
Are we on time?
Yeah, we are on time. Yeah.
Hello.
15 minutes.
Yeah, I need 15 minutes, I guess. But then perhaps you'll have some more time for other contributions. Okay, so I'll give a quick update on what's happened with the CDS consistency draft. So when parents ingest CDS, CDNS key, and CSync records, how to make sure to not mess up things. The grayed out stuff here is only for reference. It's just introductory, so I'll skip it. But the main observation on which the draft is based is that when you ingest these record types and you only ask a single name server without making sure that the other authoritative name servers for the domain would say the same thing, then you can seriously mess it up. There's various failure modes, especially in multi-provider setups, but also other kinds of situations. Yeah, so details on the backup or in the appendix of the draft itself. In particular, in multi-provider setups, not checking for consistency as a parent when you ingest these records and process them makes each party a single point of failure that can actually mess up the whole thing for all other parties too. So that removes all the multi-provider guarantees if it's not mitigated. Yeah, so each name server publishing C type of records can break delegations, and this draft is to fix it. I added one new failure mode description.
Okay.
Yeah.
Yeah. Okay. I'll try.
But I can continue talking. Here it is. Okay. Yeah. So this is just essentially illustrative. It's the fourth failure mode that came up, kind of is now in the appendix of the draft. In a KSK rollover, imagine, for example, that there's two name servers, one of which is lagging behind in replication. And the parent fetches the CDS or CDNS key records from the one that is not lagging behind and deploying new DS records. Then it's very well possible that the zone owner will see, oh, cool, the DS records have been updated. I'll go ahead and remove the old DNS key record. And then the next day, the parent fetches CDS key records, CDS or CDNS key records again, but from the other lagging behind name server, and deploys the old DS record. And then you're left without a chain of trust, and the delegation is broken, but perhaps works again next day if the right one gets queried again. So you could, of course, say, well, the zone owner isn't having his things under control, shouldn't proceed with the rollover when it isn't safe. But the same is true for the parent. The parent also shouldn't proceed with deploying DS records when it isn't safe. And actually, the CDS RFC says that in section 4.1, that the parent must not break the delegation when applying those new DS records based on CDNS records. It just doesn't say that for that to make sense, you actually have to check for this consistency. So that's just one of many failure modes and is new since the last meeting. What else is new? So the basics are unchanged, right? So you should check the consistency across authoritative name servers when you process these records. Otherwise, based on feedback from the list, I believe from Libor, we added a small, do you say rule? I don't know if it's a rule, but little provision that when you can't obtain a response from a given host, you should retry at a later time instead of prematurely declaring that name server permanently unreachable, because if you did that, then any random glitch could cause you to not look at that unavailable name server and only look at the other ones. So perhaps you don't actually catch an inconsistency, and you could mess things up, for example, in a multi-center setup when one is currently not available. And so instead of giving up immediately, it would make sense to retry with some kind of exponential backoff, and that's recommended as opposed to must, because even if you don't retry, you know, implementing half of the draft is better than implementing none of the draft. But that's what I think, and I guess we can certainly discuss it. Also, the parent may look from other vantage points to sidestep localized routing issues. Another new paragraph in the text is that well, people are concerned about the overhead from checking consistency. Actually, it's almost no overhead, because only when there is actually a change you have to do that. Otherwise, when you do the first query to the first name server and you see nothing has changed, then you can stop processing and you don't need to do the other queries, because either they would confirm that there is no change, so you don't have to do anything, or they would be inconsistent, so you would abort and don't have to do anything. So you could just save these queries and there is no overhead. And then there were some editorial changes. This is almost it, except for two open issues that I would like to discuss with you and perhaps get some input on about C-Sync. And perhaps the internet is broken again.
I can try it.
Okay,
yeah.
so let's look at the first one. So currently the draft says for processing C-Sync stuff, the parental agent must ensure that the C-Sync R datasets are equal across responses. But now it can happen in multi-provider setups that the providers have their own logic for maintaining the serials. And it could be that actually you would never have equal serials, right? So what to do about this case? It's still nice if C-Sync would work somehow, right? Perhaps somebody wants to update their glue records or something. So there's three ways I can imagine dealing with this. One is to just leave it out of the draft and not deal with C-Sync in this draft. It's an option if we, for example, think that's not a problem that has to be solved. I don't know if the working group thinks that, but it's kind of suboptimal because the situation wouldn't be really improved. Another way of addressing it is to advise in multi-provider setups that the serial processing should be turned off. Actually, it's only turned on when you set a certain flag in the C-Sync record. It's the SOA minimum flag, so we could advise to set that to 0, and then the inconsistent serial problem remains. But still, SR disappears. But what remains is that the C-Sync R data would still not be equal, right? Because the field still contains the serials, and the serials aren't equal. So how do you achieve equality? Do you just zero out that field, which is kind of a weird workaround? So I don't know. I'm not convinced of that either. And then there is option C, which I think is most correct, but also most complex. So I'm not sure if it's really practical. The question is whether consistency really means equality, right? When we check consistency for CDS, for example, in this draft, it also doesn't mean equality, because two different providers could be publishing two different hash digest algorithms, for example, and still be consistent in what keys they reference. So consistency isn't necessarily equality. And we could, for example, say here, well, for C-Sync, when you do serial processing, it only has to be consistent with the serial of that name server from which that C-Sync response is. So you compare to the serial of the SOA you get from that same name server. So it's a per NS thing, so per operator if you want. That seems most correct, but then you should still, for example, check whether they're announcing the same type bitmap and the same immediate flag and other details that C-Sync has. So there's still some parts of the R data you have to check for equality. Plus the actual data R set that the C-Sync record references like the NS and glue records. And so I think that can be defined in a way that makes most sense, but it is also quite complex, actually. I don't have to implement this because I'm not a parental agent. But yeah, so I wanted to describe how it could be done, and I have no idea if it's feasible. So input would be appreciated. And the second thing is, so for CDS processing, the RFC says the parental agent must not break the current delegation when applying the DS records. Does the parental agent, is it allowed for them to break the DNS chain of trust by applying a C-sync processing? For example, you could replace the NS records using C-sync processing such that the new name servers don't reference the same DNS keys, and then you lose the chain of trust. So I don't know, when you do C-sync processing, does it mean you do your trust chain validation with the new name servers that you get from the C-sync update before you actually apply that update, and you abort if that would make things inconsistent, which perhaps is healthy to do, but it's also quite complex. So currently, parents don't need to do this check. It's not described anywhere, but should they? That's it. Does anyone have any input? Johan is moving on his chair.
Yeah, I'm not seeing hands raised in the chat, but I guess, okay.
I
Go
can
ahead.
just reiterate my old position. I don't like this. I think we are making a mistake. I think that the definition of correctness for a signed zone is that the signature validates. And this is sort of changing that into, oh yes, but if it's important, we shouldn't only validate that the signature is correct. We should also check all sorts of places. The C-sync stuff here sort of put water onto my mill here, saying, well, this may be a rat hole of complexity. The C-sync stuff that you described above. And also requiring everyone to be consistent here. While that's a laudable goal, and here I will have to admit, because you sort of pointed at me, I will have to admit that I have read the draft several times, but I have a bad memory, so I don't really remember what it says here. But many, many moons ago, we wanted to change the delegation for .sc. This was like 15 years ago or something. And at the time, IANA had a requirement that for a change to the delegation of a TLD, every single name server had to chime in and sign off on the change, which is sort of similar. It's pre-DNSSEC and etc. But it's sort of similar. And the problem we had was that one of the name servers for .sc, well, they were no longer there. That's why we wanted to change the NSRR set, except IANA process sort of halted on those guys not responding affirmatively. So it's dangerous to have a system where you need to have chime in from all of them, when it could be sufficient to just have a very valid signature from one of them. If they are not in sync, you're trying to solve a different problem than the correctness problem, which is the distribution problem.
Okay, thank you. So I have two quick thoughts. One is the particular issue with the .se thing doesn't apply here, because the draft does have provisions to label name server hosts as unreachable when they don't work for quite some time. Okay. Okay. And second, I don't think we're questioning the correctness of signatures. So it's not a DNSSEC doubt or something. It's an attempt to solve a multi-party problem, which is a different thing.
Actually, next in the queue is Wes. Okay, that's right. Ed is, yeah, we're trying to run one queue because clearly we can't run two, and we're lucky to run even one.
Ed Lewis, I
Ed, go
can.
ahead.
What concerned me in this draft is not directly with this slide here, is that you have a line in there that if the receiver of these checks decides it's inconsistent, it does nothing. It's a silent fail. And I think that, to me, is alarming, because if you're in an operations world and you're trying to get changes made and you see nothing happening on their end, you didn't know why. It's really, this is the old serve fail for DNSSEC isn't good enough. Same problem going to happen here. I just want to raise it up. We can talk about it later.
I completely agree. That applies to all automation, even without this consistency check. I think there should be a way for registries to have some kind of reporting. Yeah.
Wes said that we could swap.
Okay.
Wearing my not monkey hat, could everyone who's had wireless issues stick their hands up? Like, is it? Okay, so it's the NOC is seeing weird issues on that access point, but we weren't sure if it's the whole room or just the side or what. They'll look some more. In the meantime, the presenters, there should be a wired connection that you can use, which should be on the table.
All right.
Oh,
Thanks.
very good to know.
The front fell off.
In any case. Go ahead, Wes.
Thanks. Wes Herdiger, ISI, and the ICANN board, not at all speaking for the ICANN board whatsoever, and also the author of the CSync draft. So these are all hard problems. The reason that CDS and CSync exist, and this is the important thing to remember, is stuff was broken. And if we want to produce a operationally viable DNS ecosystem that works really well, we should figure out ways to solve it. I actually don't care. Maybe we should completely replace CDS and CSync completely and start over from scratch. That wouldn't necessarily be a bad thing, as long as we're actually making progress toward helping the DNS be stable, consistent, and actually update. You know, I wrote CSync in particular because nobody was managing to update their parent. And I'm equally as guilty. I noticed one of my own zones a while back going, well, they don't match anymore. And did I notice? No, I didn't. So it would be, you've come up with a bunch of corner cases, and I'd love to help you solve it. But I guess my final point is, you know, twofold. One, this is still critical, right? I think having these two types of capabilities so that we get an automatically updating system is important and paramount for their stability. And then two, we shouldn't be afraid of restarting if it turns out that our past, you know, guesses on how to do this were incorrect, my own included.
Yeah, I'm also afraid a little bit of over-engineering the edge cases. Perhaps it's sufficient to do like some consistency check for the simple cases. And that's better than messing up multi-signer setups, which are likely becoming more common than in the past. And that's the motivation for why I came up with this draft. And then thinking about it, all these other things appeared, but perhaps you can just exclude them. I don't know.
Mark Andrews. Yeah, I want multi-signer to be safe. And the only way it's ever going to be safe is to have multiple checks. It's just too easy to get it wrong. Yeah, what was the other point? Automation is nice, but we can always go back to doing it manually when a name server is dead. We can recover. We've got other methods to recover. We don't have to recover every failure scenario automatically. So if a name server is dead, go through your registrar. And rules are there to try and make things right. The rules have to be interpreted sensibly. The DNS is loosely coherent. The word loosely is important there. Things will be inconsistent at some points, and yeah.
Thanks.
Okay. Thank you, Peter. Comprehensive update, and there should be, it looks like, a lot of discussion on the list on how to resolve some of these things. Thank you.
No. Yeah, sorry, Ray. Sorry, Ray. Next up is Schumann. Yeah. So excited to present. This clicker?
Yeah. I'm much shorter than Peter, so. Yes. Excellent. Puns galore. I was excited for a second that Ray Bellis was going to do my presentation for me, but that didn't work out. Okay, so I'm Schumann, and my co-instigator Christian is here somewhere. I told him to plant himself next to the mic so that he can run up. Okay, good. All right, so this is an update on the compact denial of existence draft. Some background, if you haven't been following this, is available at this presentation that we did at the last IETF in March. And since then, what's happened is the draft was adopted by the working group. We've pushed out a new revision. We've added Olafur Gudmundsson as a co-author. You may recall that he was one of the authors of the original expired spec from 2016. And just to clarify, he has promised he's going to do work and help us drive this to completion. So there's a kind of a placeholder section on our code substitution schemes, which I'll talk about a little bit later. And there's an implementation status slide that needs some updates based on new work that Cloudflare has recently done. So Victor, you already have a question?
At the end, I'm just joining the queue.
Okay, sorry, I didn't understand.
At the end of the
At the end of the presentation. Okay, you're just early.
People are reserving their spots. In
Okay, I got it. All right. Okay, so I'm just going to jump into some of the open issues through the rest of the presentation. So the first is, should we support signals for both non-existent names and empty non-terminal? So my original position was we only need one signal to differentiate these two cases. So let's standardize the NX name and retire the ENT signal. But as a practical matter, both of these things are deployed in the field today by different actors. And there's probably a reasonable case to be made that for backwards compatibility, maybe we should standardize both. And making sudden changes without giving people time to react may cause problems. As evidenced by this email thread that I've linked at the bottom of the slide. This is on the DNS operations mailing list, not DNSOP, the OARC list, where a change by Cloudflare caused some commotion. Okay, so I'll stop there and ask for comments on this one.
So Victor,
the question is, should we also standardize the empty non-terminal signal?
Sure, if I may.
yes, please.
My view is that we should standardize only the ENT signal and not the NX domain. Any RR type we standardize for NX domain has to be answerable for the NX domain and cacheable for the NX domain, which presents kind of difficulties semantically, right? You know, what is the semantics of a query that asks for the Sentinel RR type? How will it be answered by the authoritative server? It promises it exists, and it promises at the same time it doesn't exist. It's a conflict. Whereas the ENT signal can actually be answered with an empty RData and everything is good.
Yeah, I mean, that's a reasonable point, but it's like what practical, so this is related to the next slide I'm getting to about the response behavior when you receive explicit queries for these things. So as you know, Victor, originally I did implement only the ENT signal, but after some back and forth with Cloudflare, we decided to flip back to the NX name. I think there's still an opportunity to change course. So, so you're suggesting that we don't do the NX name signal and do only the ENT signal. Is that correct?
Yeah. Yes.
Okay. Okay.
Yeah.
All right. Okay, so that's a point to ponder. Let's come back to that. Should we move to that? Ed?
I'm sorry, are you done with your slides? Because my comment's a general comment, not about this slide.
Oh, no, I have a few. I'm going,
Okay.
I have 4 or 5 issues. I'm going through them one by one and soliciting comments because I thought it would be. No?
I'll wait till later.
Okay. All right. So the next question is, should we use the IANA early allocation process to get...
Tail,
Yep.
with all due respect to Victor, who I greatly admire for his DNSSEC work, I really strongly disagree as someone who, between the two, I'd like to see signaling for both. I want as much information as possible, but if we're only going to have one, NX domain is the one that I really want. There are definitely applications out there that are depending on true NX domains. And you know me personally that I've railed about this for years.
Yes.
So I just want to, give that indication that there's a lot of support for also at least signaling an NX domain.
Okay, great. Thank you, Tail. And should we drain the rest of the queue if you have questions on this point? I don't know who else is in the queue. I can't see.
Yeah, no, it's fine.
Jim Reed. If you were to have separate signaling mechanisms for NX domain and empty non-terminals, does that mean you're going to have 2 distinct RR types for that?
Correct.
Because if I remember you talking the last time was you want to have a special R type code assigned because it would do nifty tricks with the bitmap.
Yep, correct. So,
that
two
rationale would
distinct,
then disappear. Yeah.
yep,
Okay.
two distinct, these are meta types, right?
Yeah.
Pseudo types.
Okay, thanks, you.
Yep. Christian?
Christian Emerald, Cloudflare. I certainly don't oppose us implementing the end sentinel as well, but I strongly support us implementing the NX name R type, simply because you have the downstream issue where DNS relayers simply have no other way of relaying the NX domain message otherwise to verifying clients.
Right, yeah, you want an explicit signal that you can easily interrogate, right?
That is correct.
And so Christian, while I have you here, did you also tell me recently that Cloudflare also has code ready to go for the ENT signal if we have consensus
Yes, we
to do so?
If that is the case, that is what we come up with.
Okay, great, thank you.
Okay. So to the working group, I will clear the queue, and you only raise your hand if you have a question on the issue Schumann is presenting. Yeah.
Okay, great. So the next issue is, should we use the IANA early allocation process to get real code points? We talked to Olafur, who happens to be one of the expert reviewers for new RR type allocation, and he pushed back a little bit. He said, let's defer, let's get the details of the spec right before doing that. So the only argument against that is, we might cause implementers to change again down the road. So I wanted to ask explicitly if anyone has any counter arguments, but in principle, I'm okay with Olafur's stance. So anyone have any strong opinions about that?
Yeah, I think we're going to need to go ahead and get through all of the issues.
Okay.
Because there's plenty of them. It sounds like there's plenty of room for discussion.
Yep.
And we can go to the mailing list or even an interim if that turns out to be the right thing. But we
Okay.
do have to keep moving for now.
Okay, great, sounds good. So the next issue is explicit queries for the NX name or ENT type. So right now the draft doesn't say anything about it. The behavior is undefined, but people have suggested that we explicitly define what the response behavior is. I kind of sketched out what it should be, and we're planning to put it in the draft unless anyone has any objections. So that's the question. Going once. All right. And the next issue is the slightly trickier one, which is R code restoration. And what this means is finding a way to put the NX domain number 3 back into the R code field of the DNS header. So opinions diverge on this issue. There are some people who simply don't care. Other people have strongly held views that this is essential to do that for operational reasons, tooling and other things that use it, and impact on name resolution APIs, etc. There's two cases. One is the non-DNSSEC enabled queries, and one is DNSSEC enabled queries. The first one is pretty easy. Authoritative servers could just give a traditional NX domain response and be done with it. For forwarders, for resolvers, is a little bit more complicated. They can examine the NX name in the type bitmap in responses from authority servers and then convert the R code back to NX domain in responses it relays back to downstream couriers. So the trickier one is DNSSEC enabled queries. So there was a thought floated on the list about whether we can just unconditionally set R code to 3 with the expectation that resolvers would just do the right thing and only examine signed data in the response. Alas, I did a study of the empirical behavior of a bunch of resolvers, and the results were not encouraging. So things will break pretty hard. But one or two implementations gets it right, but we can't do it. So we really need signaling if we were to do that. I'm not going to go into any details. So I have a sketch here we can discuss on the list about defining a new EDNS flag and a conditional behavior based on that. But I want to back up a little bit for now and ask the more general question: do we in fact need to solve this problem and have a signal solution for replacing R code 3 even for DNSSEC enabled queries? I know some people have privately told me we have to fix this problem, but I'm throwing it out now to the group. And I have one more issue after that, Suzanne, and I'll be done.
Yeah, great, thanks.
So maybe I'll move on to the next issue, and then you can line up if you have questions about this previous one too. And the last thing I have is to recommend or not. So The original reason I got involved in this work was to help standardize an existing deployed practice in the field by a number of commercial DNS operators. And I thought that was essential that the IETF do that. However, for new online signing implementations, what should we say? Should we be encouraging them to deploy this protocol, or in fact do the opposite, like actively discourage them? Because if you think about it, if they just deploy what is already standardized today, minimally covering NSEC or its NSEC 3 variant, which give essentially by the book negative responses, then they don't have to worry about these issues with missing NX domain signals or how to recover it from some new flag in some other protocol element deep inside the message body. So they might be better off doing that. So that is my question. So should this specification say something about whether new implementations should at all be doing this or not? And I think that's the end of the issues.
Thank you. Queue is open.
Okay, Ed.
So I was reading this draft. I'm quickly coming back up to speed after being out for a while. And there in the draft specifically, there is one place where you're going to respond, where the draft says respond with an NSEC record with just the NSEC bit and the RSIG set on. Now, I remember specifically that was forbidden in the definitional documents for DNSSEC, RC 4035, section 2.3. I actually went back and looked at it. Because I remember this was one requirement I remember really by heart, that no name should be created just to have that. But what's interesting is I went down the paragraph and there was actually a rationale that says that one of the reasons was we want to make sure that the signed version of the zone and the unsigned version of the zones were coherent, right? And that came back to me this morning just before I came down here. And this kind of, the word scares is not a really good reason, but it makes me be alarmed here with what we're trying to do here. I mean, I like this idea. I think it's really needed to have compact denial of existence. I wonder, though, if it's better to create a different RR type and say, I'm answering negatively, like NSEC 5, to be sarcastic. But we need to have something else. Maybe we need to get away from trying to overload NSEC to do this, because I think we'll have operational issues. That's going to be my theme of many of my comments. If we try to overload things where operators have to now assume, what were you thinking when you wrote this to me? I mean, I really applaud the efforts to accomplish this, but I think in trying to do this, we're going to be upending so much of how the protocol had been developed to get there. And that's my concern. I think there needs to be more discussion on that. I'd like to get to this goal, but I think I'm a little alarmed when we try to overload things that we have in place.
Yeah.
So.
Okay, yeah, point taken. So I'll have a chat with you later about the specific point in the spec that says that. And who's next?
Paul Hoffman is actually next in the queue, and then Tal, and we did close the queue.
Great.
Go ahead.
So back on your slide about IANA, don't worry.
Okay.
I absolutely agree with Olafur on this one.
Okay.
Do not say something is true that will probably change in the future in the IANA registry. We have so many more problems with that than we do implementers finally getting off the private use and onto the standard one.
Okay, great. Thank you, Paul. And Tail?
Yeah, Dale. On the issue of recommending things, I just want to say that I do think you should have guidance, because my understanding is that the reason Cloudflare and NS1 are not doing 4470 is that they have a fundamental structure of how they retrieve their queries from their database in order to provide answers that make 4470 untenable to them. I mean, if I'm wrong about that, then please have them just switch to 4470 and let's not do all of this. But if that's the case, that there are some like kind of back-end implementation issues, then I think that's the guidance you provide to vendors, to say, in general, we'd prefer you do 4470. It's going to work out a lot more simply for you. But in some special situations, then you'll need this.
Right.
And you had one more issue on the previous slide I think I wanted to comment on, but I don't even remember what it was. The signaling scheme. Yeah, I do think that we should provide a way to indicate a resolver to indicate, hey, I'm modern enough to understand that I want to convert your answer to 10x domains.
Right. Okay, thank you, Tail. And then, so the one more point I want to make about the recommendation, it's not like for other online signer implementations, it's not like this hasn't already been deployed in the field. There are the other providers that are doing by the book online signing with negative responses and at scale. So apparently it can be deployed.
It can be deployed because it is. Thank you, Shuman.
Yeah.
It does, as we said a few minutes ago, there are several open issues here, and a couple of them are complex. So let's go ahead and take discussion of the mailing list. And if it turns out that the next way to make progress on it, we will do an interim if that seems helpful, and we'll keep this moving.
Yep.
Thank you very much, Shuman.
Thanks.
All right, I will. Yep.
Hi, I'm going to be presenting, so now we're in the things that are not yet in the working group area. So this is one that's not yet in the working group. This is a draft that we have a 00 out on that is specifically about publication of the trust anchor for the root zone. I'm doing this. I actually wrote these slides yesterday without talking to my co-authors. They may disagree with some of it, but here we go. Oh.
Yeah, it's for you.
Oh, whoops. Okay. So just a couple slides. Why should we revise the existing RFC? Gee, didn't we do that recently? Why are we revising it so soon? And then next steps. So a couple slides on why we should revise the existing RFC. We've in the 00, and by the way, we are keeping a good list, in the draft of what is being revised. There was an erratum that pointed out a fairly significant error. So we should fix that because this is actually important and codable. Many people over time have said, why do you only have a hash in the trust anchor stuff? Why don't you actually put the key in? So we now optionally put the key, have said we can optionally put the key in. That's probably going to be the most discussed part of all of this. And we don't need to discuss today. We only need to discuss if it gets adopted by the working group. But so the XML format is changed so that it can also have a public key. And then going forwards, if IANA wants to do that, they will stick the public key in. The DNSSEC practice statement, the reference is old, so we updated that. And one thing that came up during, as many of you know, IANA is discussing how to do an algorithm rollover for the root. And so there was a discussion of that in the community. There was a side meeting and such like that. One of the things that came up is people said, oh, that's XML. Is it really XML? Are you going to allow like XML comments? And they said that in a way that got us nervous enough where we want to say yes, it's XML, comments are going to be allowed. And that might actually be helpful because most XML documents people look at before they jam into anything. And so IANA can put comments in such as like IANA is going to do something later and such like that. And that's the best way to communicate that to somebody who's looking at the thing that holds the trust anchors. So then there's some other things that we might want to do. There is in there how IANA publishes a PKIX and a CSR file and when. Some people like that, some people don't. That obviously has to be a discussion with IANA about what is their intention, but they will follow what we do. So there has to be a good dance there. The current Appendix A in the RFC talks about the rollover in the future. We already did the rollover. We learned some things. We learned some things about the trust anchors. We should probably document them. And then there's going to be the normal miscellaneous cruft. The answer why so soon? Well, actually, August 2016 was a long time ago. And, stuff has happened since then. We did learn things. And we know that IANA is going to be, doing, a key role in the not so distant future. Again, keeping with RSA 2048. Maybe we can do something in this document to make that rollover better for the people who rely on the trust anchors. And is there anything we can do in this document that will help with the intended future rollover, which in the longer future of the algorithm? So if the working group wants to adopt it, great. If not, should these changes be made by IANA in some way and such like that? I would sort of prefer that the working group takes this up so that there is a chain of RFCs, but it's not necessarily required. And the other thing that we want people to do, implementers who are using any trust anchor files, please look in your code for assumptions you have made based on the old RFC. Especially, are there going to be comments? Is the XML in this exact format, or can we add optional things? So that would be really good. And that was my last slide.
Thanks, Paul. Tim Wasinski, definitely in favor of adoption. And as a chair, I'd like to sort of get the working group to sort of get their heads around this and sort of like, let's move this forward kind of thing for the rollover.
Okay.
Thank you.
Right. Other QE people? Nope. Cool.
No?
Great.
Okay.
Thanks.
So read the draft, think about it, comment on it. Thank you.
Right. There he is.
Okay, this should hopefully be fairly quick.
Oh, I would do that one.
Okay, so QD count is usually 1. Is this going to work? Forward. Okay, so following some quite active discussion on the list back in, I suppose it must have been March time, relating to the threads implementation, we had a lot of discussion on the list about what QD count should be. And I believe it was actually Tim suggested, it happened to be while I was doing a NOARC meeting, that somebody should write a draft on this. So I did, and Joe Abely helped as well. So the current position is that Step 13, RC 1035, or 1034 and 1035 has some ambiguity about the QD count. In part, this is because it predates RC 2119 requirements keywords. It's a 16-bit field, but most of the time this is mentioned actually in the draft. It says the question, the domain name in the question section, that kind of thing. So it happens that Paul Mokapetris was in Yokohama. I don't see him here today. I asked him, what was the actual intent? And this is a paraphrase because it's just conversation. I didn't record it. But the paraphrase was that it wasn't intended to constrain the query to only one question, so that if suitable semantics were subsequently defined, it would actually be possible. So our contention is that we don't think it is possible. There are fields in the response of DNS response that there are only one of, and specifically the R code and the AA bit. And if you've asked multiple questions, it's difficult to specify which of those apply to. You could have one domain that exists and another domain that doesn't exist. You could have a mix of authoritative and non-authoritative data, and there's no way to know from the answer which is which. So the intention of this draft is to basically settle this matter once and for all. It updates 1035 to say that QD count is 0 or 1 specifically only for the query opcode. It doesn't constrain it for the other ones. It does also survey the other opcodes, and I'm aware that Johan Stensheim has a draft for a more generic notify mechanism, which does use a QD count greater than 1, but the draft doesn't actually restrict that, but I could put in an informative reference to that, because that is something that's allowed. Digging back up some really ancient history, way back when I was working for Nominet, like 10 odd years ago, I wrote draft balance DNSX to multi-queue types, which was in theory at least a solution to doing this if all of the queue names are the same, but all you want is for example, A and quad A or other related records all at the same time. So if there's demand for it, I'm still happy to revive that draft. In fact, I did actually rev it back in April, which I've forgotten I'd done. So that's basically it. Any questions?
Thank you.
Yeah, would you mind going back to slide the one before this, 6, I guess? I'm feeling dumb. What would Why would you have a QD count of 0 in a query? Like, what am I missing?
The one exception, if I recall correctly, is that DNS cookies allow for a QD count 0 request simply for essentially establishing comms without actually giving away the question. Looking over at Mark, I think that's correct, isn't it? Yeah. Ted.
Peter, I think. Peter?
Oh, sorry.
Oh, yeah.
Peter was next in the queue.
Oh, there you are.
Hi, it's Peter. Just very quickly, I understand all of the arguments. I think it makes sense, but has it been a problem? I mean, why are we solving this?
Right. I'm attempting to solve it because there is an implementation out there where a naive implementer who doesn't participate in the standards process tried it and got it working in his own private environment. We want to make sure nobody ever does this for real on the public internet.
Right. So I can give you a little bit of background on that, which I think maybe is useful. But my main concern about this document is that it's really big and it should be as small as possible. So there's a huge amount of analysis about like the history and stuff like that. It's all super interesting and it shouldn't be in this document. The case that you're talking about is that it turns out that OpenThread, which is an IoT thing that is actually in pretty heavy use, the Matter ecosystem and various other ecosystems use it. The OpenThread implementation of the DNSSD client that does basically does DNSSD lookups, which at one state involves looking up a text record and a PTR record at the same time, uses QD count equals 2 for that particular case. In that case, the name is always the same. And so it sort of makes sense. And as you said, what happened was the guy that was implementing this had not read or actually he had read the RFC. He read the RFC didn't say don't do this. And in fact, it kind of implied that maybe it could be done, although it would be weird. And he thought, well, this is the weird case, let's do it. And so we now have running code out there that's doing this. I had to write an implementation of the server side to make it work. And what we've experienced in practice, and to me, this is what the document really should be addressing, is the operational concerns here. What we've experienced in practice is that different name servers give different responses when QD count is 2, okay? Some of them return form error. Some of them return a no error and no data, like no response at all. Some of them return an answer to the first question. And so I think what this document definitely should do, well, there are a couple things I think it should do. One is it should say, don't do this, right? The other is, if your implementation receives a question with QD count greater than 1, this is the one thing that you should do.
Yep.
And then
the draft does say return form error.
Right. Yeah. And I'm just trying to get what I'd like the draft to. I really want the draft to be as small as possible, because right now when I read the draft, basically I just get pissed off, which is not your fault and not your problem, but nevertheless, I think, this is not a moral question. This is just like an operational question. We shouldn't. That's all the draft should be talking about. And then the third point is that it might be worth documenting that there are implementations out there that do this for a particular corner case, and what to do when you see that. I don't know what the answer to that is. Personally, I don't see like bind 9 going out and implementing QD count equals 2. No. And that being the case, then there's no reason to I mean, the client that does this is going to have to be responsible for dealing with the response it gets back. And so what I most want is for the response to be consistent,
yeah.
which you're doing.
I'm pretty sure bind does already return form error in this case. Okay, so for the for those that can't hear Mark, he said that we do return form error, but IC bind returns form error, but omits the question that was in the query in the first place,
which should be
because
fine.
It's not semantically correctly defined.
Okay.
Okay. Well, thanks, Ted. I'll take it on board. If there's any other feedback along those lines,
Liman was next in the queue.
What we should or should not say in the draft.
Yeah, Liman was next, and then Jim.
Thanks. Lars Lehman here from NetNode. I haven't really heard why this is bad. I don't want. I'm a man who doesn't want to limit options. And if you send a QD count of 5, then you just have to deal with whatever comes back, right?
Well, we're
it's your
defining
problem. What you could say is that the responses from this, or the behavior, expected behavior from the server, is not well defined. So be prepared to be hit by something strange, but don't prevent it. If you have, so Ted said there are already stuff using this, so they obviously have a mechanism that works. Why should we stop
but
them?
I suspect they haven't actually coped with the edge cases that we've documented.
Their problem.
Perhaps.
Send treat and you get treat back.
I mean, yeah, this draft is intended to be very short. I mean, Ted said it was very long. I think it's only about 3 pages of text, other than the boilerplate. Ultimately, part of the rationale is we want to stop having this discussion with other implementers in the future, because this shouldn't happen on the public internet. It doesn't happen on the public internet, and we want this written down in black and white. This is incorrect.
It doesn't happen today on the internet because it's not well defined.
But I think Lars, the point is that it isn't actually possible to well define it without doing a bunch of extension work. And if you're going to do the extension work, you might as well just define something else, because so you're not eliminating the possibility of asking multiple questions, but you're defining a way to do it that's not just setting QD count to 2, because setting QD count to 2 is something that all of the servers that are already out there need to be able to do something simple.
Indeed.
And so I think saying that they have to return form error is a great way to deal with that. And then you've got a document that uses EDNS0 to add multiple RR types, which I think is the exact use case that we care about.
Indeed, yeah.
Yeah.
So we'd kind of like feedback on whether the working group has interest in reviving my multiple Q types draft. Yeah, I see thumbs up from a few people. But I guess we'll take that to the list and to the chairs.
Yeah, please.
Yeah.
My next to the queue.
Jim?
Yeah.
Yeah.
Jim Reed. I think just put things a bit more succinctly than Ted said before. I think we have to have a very short draft that pretty much says don't use QD count more than 1. Simple, unambiguous, clear. Yes, you can use these things, as Lehman said, for other particular purposes, but let's not get involved in that. You could say if you choose QD count greater than 2, bad things might happen and you're on your own. But a clear statement, QD count cannot be more than 1, is a good way forward. And a very short RSC that says that. Now, the other thing, Ray, is that there's a lot of other interesting information that was in the document. You're talking about all this historical context and things. I still think that should be written up as an informational RFC, because something, to my mind, we've been very bad at is documenting how we arrived at previous decisions that we've taken. And a document like that gives a historical background would be very, very helpful. I'm thinking particularly now the discussion we just had about compact compressed denial of existence stuff. It reminds me very much of the white lies and black lies discussions we had in DNSSEC was being done all those years ago. So having a document that just says, here's how we arrived at that decision, is a separate RFC that we can refer to if people ask, why did you put this other one that says Q defined must not be more than 2? One, sorry.
I do have some of the other historic context in the multi-Q types draft, so maybe it doesn't need to be an entirely separate draft.
Yeah.
And obviously, by necessity, that is a longer draft anyway. The other option may be, and I'm not sure if Ted's not paying attention just now, is whether that should simply just be moved to an appendix of the draft.
I would basically keep the RFC document that says don't use QD count greater than 1 should be a very short, concise document. If it's more than a paragraph of
I've seen a lot of people around you saying that the appendix idea is actually preferable.
So basically, if we're talking about a short, simple document, instead of saying send text, you say send deletions.
Works for me.
I always try to write as short doc as possible anyway. Joe
But
maybe had different ideas.
That seems to be the consensus in the room to an unusual degree.
But we could I'd be very happy to look at basically trying to make the normative parts of this as brief as possible and moving the historic context into an appendix, so that it's there for the history, but doesn't confuse the reader by going into it too early. Okay. Any other questions? No?
We're close.
Okay. Oh, okay. Thank you.
Thank you.
Willem has next.
Yeah.
And Willem? Yes. Hello. And there you are.
Yeah, excellent. Thanks.
Okay, this is about DNS out of protocol signaling. And so if you turn that into a acronym, it spells out oops. Hence the monkey. So this will be the last time I point this out. So what's this about? So it's a protocol that bridges the gap between DNS and BGP. BGP actions can be triggered by DNS events or conditions. For example, if a DNS Anycast operator or authoritative Anycast operator spins up a node on a remote location, it wants the zones to be loaded first. It could be a whole bunch of zones, like millions, or it could be very large zones. And it does not want that node to be available for queries until everything is ready to serve. So only when all zones are loaded, announce the prefix. And similarly, if one of the zones expires because it cannot reach the primary again, or because a signature is about to expire, a prefix could be withdrawn. And so the motivation to standardize this is by operator request, especially, or where I heard this personally, is the operator SIDN, which is the operator of the .nl zone. They have their own Anycast network. They use not DNS to serve the .nl zone. And they asked for this feature or this mechanism, or they requested this feature by CZNIC, and CZNIC implemented this in not DNS based on dbus. And that's what they are using now, but SIDN would like to have more diversity of software in their network. They also would like to run NSD and bind and PowerDNS and whatever. So they would like to see this standardized. And well, but you know, dbus is perhaps it's just a good fit, but it is local to the system. So there might be other signals which are better fitted with communication that goes out of the local system. We don't know. So dbus has the advantage that there are plenty of tools. It has the disadvantage that it might not be as generic as we would like to. It's quite Linux specific, systemd. And also, yeah, what I discovered myself is that the startup order of things matter. So your DNS server has to be started before the listener of the dbus events. So I presented this in the last IETF 116, and then I mentioned that we needed to inventorize what conditions are interesting to signal and how those could be identified and what associated actions could be interesting and what signaling mechanism would suit those best. And so in the current version of the draft is a whole list of conditions which are interesting for this mechanism, at least that we think. So the number on the left is the section number in the draft of where this condition is mentioned. And the resolve tick box is if this also applies to resolvers, Anycasted resolvers. The paren argument is if a parameter could influence the signal, and the argument that is contained within the signal. But the most interesting column is how to identify the condition. So a condition, some of the conditions, like is the server running and can it respond to queries, or is a zone loaded and ready to serve, can already be discovered simply by querying the zoning, right? And but even though that is the case, that might be very resource intensive, especially if you have a lot of zones. So for some of those conditions, it's even though you can also identify it from the outside of the name server, it might be well worth doing signaling from within the name server. Yeah, so last May there was the Connect to Port 53 DNS hackathon preceding the RIPE, and I worked on a hack together with Doris Hauser, also known as Dodo, Henrik Kramslund, Liman, Stefan Ubink, and Willem Prits. And we set up a anycasted network with 3 secondaries located in Amsterdam, Stockholm, and Frankfurt that ran 3 different versions of authoritative name server software. And we used 3 different signaling mechanisms to yeah, well, basically only respond to the signal a zone is updated to a new version. And use that signal to announce or withdraw a prefix. And we did it in such a way that if the serial number of the zone modulus 3 is 0, then the not DNS would announce the prefix and the other would withdraw. If it would be modulus 3.1, then it was bind's turn, so to say, and if it would be 2, then it would be NSD's turn. And with version.bind chaos text query, you could see which name server was answering the query or was reachable over the IP address, at the IP address. Yeah, so from this experience, we also, so the document is in a requirements or collecting requirements phase. And some of the signaling mechanisms that we were added since last IETF are DOTS, of the denial of service and threat signaling, which was a IETF group. And what I like, it basically ticks all the boxes, except perhaps the last one, which is client library availability. But it can do all kinds of communications, not only local to machine, but inter-operator, inter-machine, etc. Yeah, at a hackathon at RIPE, also MQTT was suggested during this hackathon. I hope to get more information about DOTS, but yeah, I only learned that yeah, that was unclear what the software support was, so maybe I have to look a little bit further. Yeah, I can skip over that. So this is the last slide. So concluding, there's clear operator interest in this. All the other, or I have collected other authors on the draft from the different implementations, and they're saying they also heard that operators are interested in this. Not DNS has something implemented already based on dbus. The operators would like us to align implementations, that we have something like this standardized. But yeah, we're still perhaps in the evaluation of signaling mechanism state. So my questions are basically, do we need to converge first on that? Or could we have multiple of those signaling mechanisms in the draft? Or perhaps restrict the whole mechanism to be locally to the system only? Yeah. And also, do we need to keep a record of this evaluation? And that's basically it.
Thank you, Willem. Go ahead, Ben.
Hi, Ben Schwartz, Meta. Could you help me understand why this is specific to DNS? what aspect of this problem would be different in the context of any other protocol that similarly needs to bring up a service, confirm that it's running, and then notify BGP to announce or withdraw the route?
Yes, it's not specific to DNS. Yeah, only specificness is that there are some conditions that can only be detected from within the name server, or are only worth detecting from within the name server, because it would otherwise be too resource intensive.
Thanks. So this seems like a valuable thing to define and standardize to me, but the most logical structure that comes to mind for me is something like a specification that essentially lives close to BGP, saying here's how you inform a BGP server to withdraw or announce a route, and maybe a BCP on the DNS side saying here are appropriate conditions that you ought to check before deciding whether to announce or withdraw that route.
Yes, that's yet another intake on this. Indeed, the receiver could be the BGP daemon, I guess.
Yeah.
Right.
Yeah, Ray Velis ISC with my root server operator hat on. Ben, to answer one of your points there, in our situation, we don't actually tell our BGP systems to withdraw the route. We actually just remove the prefix from the loopback interface, and that then automatically makes the BGP speaker do the right thing. So yeah, you can't necessarily hand it off directly to the BGP daemon.
Okay.
And I think it would probably be quite complicated to do so.
Okay, sounds like some further discussion, which is what you're after. So review the draft and review the implementation information that they've provided. It's really good to bring that also into the working group. Thank you.
Thanks. Thank you.
Johan?
It might not be tall enough for you.
Okay, so my name is Johan Stenstam. I work for the Swedish Registry, and well, a year and a half ago, the Swedish Registry had a rather bad wake-up call, and this is stuff that is resulting from that. So what happened was that in our zone generation pipeline, as in the stuff that sits between the registry system and the public name servers, the stuff that verifies the correctness and adherence to various policy requirements of the unsigned zone, the signing of the zone, the validation of the resulting signed zone, etc. That pipeline of checks and tests and stuff failed. And what really failed was that in spite of us being redundant and nice and having multiple pipelines next to each other with multiple HSMs, etc., well, both HSMs failed at the same time. That was unpleasant. That said, had we done this in a better way, we could obviously have validated all the generated signatures, and we would have detected that the generated zone, the signed zone, was not a valid zone. But we didn't. I cannot really explain this, because at that particular day, this was a shock to me that we didn't, but never mind, we didn't. And in the sort of aftermath of this, we looked at ourselves and we looked at our code and all this stuff that is the zone generation pipeline for .se and .nu, and we said, this is not good. This is a bunch of old Perl stuff, various bash scripts, custom code, lots of runtime dependencies, horrible to maintain, and guess what? Because it was horrible to maintain, it wasn't very well maintained. people entered into a mode of, don't touch it, it works. It's been working stably for 10, 12 years, so let's not play with this, because if we touch it, it will probably break. I'm not justifying this in any way. I'm just saying that's the way it was, and we decided, let's not do that again. So let's restart. Let's try to do this the right way. And the reason why I'm here is, one part is to explain the process of going through, let's call it first principles, and look at the requirements for this kind of stuff. The second part is that, well, major CCTLDs, and at least for me, Sweden is a major CCTLD, they all have this stuff. Every single TLD on the planet has something like this. In some cases, it's extremely well maintained and under full control. Everyone knows exactly how it works, and it's very robust and nice. But without pointing fingers at anyone but myself or the Swedish registry here, I've talked to many of my compatriots at other CCTLDs, and let me just say that we are not unique. There are many places where the sort of Swedish situation, sort of pre-incident, is where we are today. And perhaps the time is ripe for a more open discussion about these issues, sort of finding the best current practice for how to actually design a zone generation pipeline that is robust and doesn't fail on a Friday afternoon when everyone is already bringing out the beer, which is actually what happened. So I will go through the requirements here, and then I will speak a couple of words of what the result is at the end. So we decided that we don't care much about exactly what tests are performed where. There are tests. There will be new tests. Old tests will probably be retired when new tests are better. So it's more interesting to have the right framework for dealing with tests, what tests could be active or not active, having standardized mechanisms for adding tests, etc. And I already spoke about this part where we want to make this an internet draft, which is sort of to trigger the more general, the generic discussion, which is larger than just .sc. In the old system, there was all sorts of, well, non-standardized ways that data moved from one step to another. In the new system, we say that it should always be standardized protocols, primarily AXFR or IXFR. This is to make it easier to use standard software. We really want to avoid having custom software in the critical path. So we have a zone transfer that comes in sort of at the start of the pipeline, and it goes through a number of steps, and each step should always be, with our choice of term, well-vetted, publicly available software. It shouldn't be our custom code that is only used by us, because that has a much higher degree of risk of having bugs in it. So that's the sort of start for us, that these are the principles we want to have this new system designed from. And well, it took some time, but I think we actually got there. So although you can always change your principles if needed, so far we haven't had to do that. Here you have the result. And without going into detail about this, to the left you have the registry, which is something that generates the unsigned zone. And then you have two parallel pipelines, the one at the top and the one at the bottom. It has a number of steps, where one important step is the thing called ingress validator. Then you have zone signer, and then you have egress validator, and then you have distribution. Under the zone signer, or between the zone signers, you have various HSMs and stuff. So there's nothing strange with this. It's just a number of steps that you go through. And you're trying to be robust. Well, what about
ingress validation versus egress validation. Why do we do validation in two separate places? That's because we have to do validation of correctness, where correctness means adheres to our policies on the unsigned zone, because if we do find a showstopper issue, it's simply too late if we find it after signing, because then there's no way of rolling back easily. So we must make sure that the zone that is being signed is always a zone that we're prepared to publish. Because if something stops upstream and the zone that we get from the registry is broken somehow, we should be able to re-sign and re-sign and re-sign the zone that has reached the signing step. So any policy errors must be found and detected before signing. Then we have the signing part, and this is obviously a part that interests us because that's where we had problems. So it's obvious to everyone, even to us, that we should do validation of generated signatures and verify that the NSEC chain is complete and all that DNSSEC stuff. But is that enough? Shouldn't we also try to define some sort of invariant to make sure that the signing step doesn't make any other changes than adding signatures and NSEC chains, etc.? But how do you define that? Well, what we came up with was that if we save a checksum, which is essentially zone MD, if we save a checksum of the unsigned zone before the signing step, then the signing step typically will both sign the zone and update the zone MD, etc. So it will not be the same zone MD afterwards. But if we strip off all the DNSSEC stuff and we strip off the new zone MD and we reinsert the old zone MD, it should have the same checksum. And then suddenly we have a one-to-one invariant that says nothing has been modified in this zone apart from the DNSSEC stuff that we validate separately. And then we have the sort of tied down security that we really wanted. Because of the wish or the requirement not to have any custom software in the critical path, that means that it has to be sender software that gets the zone, works on it, and sends it onwards. And all the checks, all the tests have to take place to the side, so to speak. We don't want to have that in the critical path. What we're using right now is the recently introduced verify attribute in NSD, which is something that NLFs had before in the shape of something called CreDNS, and now it's integrated into NSD. So basically the zone arrives in NSD. NSD does a call out to an external verifier to the side. The verifier does whatever it wants, and when it's happy, it will send back, I'm happy, and then the zone proceeds. If it doesn't send back the I'm happy message, the zone will not proceed. And if this is the egress validation, then presumably no new zone will reach the signer, and we will just keep resigning the old zone, which is correct, but not as up to date. We're mostly done with the implementation that resulted from these requirements. We have a static Go binary implementation of this external verifier that we call from NSD. It's extensible in the sense that it has a defined API for individual tests. It's possible to, through configuration, turn on and turn off the various checks and balances after what your needs are. I'm less interested in exactly what tests we have because, as I said, tests to me come and go. I want to have a mechanism for dealing with them and making sure that all the decided tests are actually executed. We intend to make all of this open source. So in the end, this should be something that others can either just take wholesale if they want, or my preferred option is, of course, collaborate with us on actually making this better and sort of support this discussion of
what is really the right design for this kind of thing, because they are sort of important to the internet. Going back to the document, which is really why I'm here, that's also complete in the sense that all that we think should be written into it is written into it. But obviously, because it comes from a single source, which is the Swedish registry, we may try to make it generic and nice and good, but it would clearly benefit from input from more parties. So my hope is that others have an interest in this, and I know that there are others that have an interest in this because they've said so. We will just wait to see for that to happen. And obviously the other part is that we need more review. So if this is deemed to be relevant and interesting to DNSOP, we suggest and would really like to see this adopted. And that's that.
Yes, thank you. We're at about time. So I think that, but I don't see anybody in the queue anyway. So the thing I think is have people read the document, opinions, comments, and we will see about a call for adoption. Tim is in charge of the timetable for that, but well, yeah, we will see about a call for adoption. Thank you. And I think you're doing also the next.
I think I am, which is why I'm not stepping down yet.
Yes, I realize. No, you're doing Jakob's presentation, so Ray is doing yours.
Well, just let me know. I can stay here forever, but I think we will all be kicked
Well,
out
the
at
meeting
some
breaks in 20 minutes, so please
Yeah.
don't stay here forever.
point. That's fine. So this is the notification thing. Well, we did this in Yokohama, as some of you may know, and then it was extremely short and no questions, etc. So I don't want to reiterate what we did then, but just rather quickly recap and say what we've changed since then, and well, to be honest, ask for adoption. So we have a problem statement here coming from the issue of CDS and C-Sync scanning in major TLDs. But just to be clear, that's not the only side of the scanning problem, because the other side of the scanning problem is that not every parent zone in the world is a TLD. And the TLDs are sort of nice because they have resources. They can devote hardware and staff and effort to external scanners and well, collect the results and deal with it, even if it's horribly inefficient. But then you have all the other smaller zones. They won't do this. And saying that everyone should have a scanner because they have 2 child zones is sort of, well, a lot of complexity for very little gain. So perhaps we could do something, well, slightly more efficient. The other part of the problem statement is, of course, all the multi-signer stuff that both Peter and I have spoken about repeatedly. And here, it's not so much about efficiency. In the multi-signer case, there is a difference, because when the keys roll, stuff breaks. So we really need a mechanism for multi-signer to work nicely, where we can inform each other, when different signers can inform other signers when they are rolling keys, so that we collapse this vulnerability window when stuff is broken to nothing. So in the first case, it's efficiency. In the second case, it's really a showstopper issue. And as you're probably aware, the proposal is basically, let's generalize the RFC 1996 notify specification by adding the ability to send other RR types in the notification. In RFC 1996, it's just notify with an SOA in the notify. We suggest that we add the ability to send a CDS, a C-Sync, or in the multi-signer case, a DNS key in the notify, just to specify what kind of notification we're talking about. And the security model doesn't change, because this is just a speed hack in essence. We're just saying, please check now rather than wait until sometime later to check. But when you check, you should check with exactly the same set of logic as you would otherwise.
be that CDS consistency requirements or not. But we do have a couple of questions here that are not clear what the answer is to. One is, of course, is this needed? There are TLDs that say there's no problem to solve here. We can scan, no problem. And then there are other problems that other TLDs that say we will not scan at all. In some cases, it's the registrar that should do the scanning, etc., depending on what the business relationship is between the registrar and registry, etc. On the other hand, there are other TLDs where this would be really appreciated and good, and Sweden being one of them. So that is a question. Another question is, of course, where to send the messages. And then finally, we have the question from Victor at the tail end of the Yokohama meeting, where he said, if you're sending these notifications to a service, not to a name server, why do you reuse the DNS protocol? Why not do something else, like a REST API or whatever? So let's just talk about that really, really quickly. My view is that different zones will have different needs. Different zones will have different solutions. And this is just adding another ability or another alternative to the smorgasbord of how to do stuff. And that's fine. So I'm really not looking for the thing that everyone must do or they are not doing it right. I mean, after all, zones make a decision on whether to sign or not. It's fine to do either. If they sign, they make a decision whether to publish a CDS or not. Either is fine. And I suggest, or we suggest, that they make a decision on whether or not to listen for notifications, CDS notifications or C-sync notifications. If someone doesn't do this and someone else does it, that's fine. That's obviously up to them and what their needs and requirements are. So I don't see a need here for this to be the perfect solution for everyone. Then we have the where to send them. And I will, in the benefit of time here, just skip past this because we talked about this before. And we have this part also that we sort of talked about. And again, the key issue here is that in many cases, there is no RRR model. It's just a parent. And this would work just fine. In the case of an RRR model, in most cases, it still works fine. For instance, Sweden uses the RRR model, and the Swedish registry does scanning. So it really doesn't matter if we do send notifications or not to the issue of does this work with the RRR model, because the RRR model is an issue of whether we can do scanning in the parent or not. So anyways, whatever, if the registrar wants to receive the notification at the end of the day, they can probably sort this out somehow, or not. If they cannot, they haven't lost anything compared to not doing this. And this is the last slide. Going back to Victor's comment in Yokohama about why not just do something else, why reuse DNS protocol. Our view is that in the TLE case, you could probably do whatever. But in all these other cases, all the mom and pop zones, all of academia with 150 departments under the university, all of Swedish healthcare, all these structures where you have lots of zones with organizational boundaries, etc., that are not TLDs. In those cases, there will not be a separate scanner thing. They don't want a new thing to maintain. They don't want something that speaks a REST API or whatever. But if they can just turn on sending CDS notifications in bind or whatever to the parent, and in the parent, in most cases, that will probably be something that can react to one of these notifications without actually running a scanner. But if I get the CDS notify, I can act on it. So we are sort of reducing existing infrastructure here, trying to avoid forcing a requirement for additional complexity and additional services. Although I fully agree that in the TLD case, Sweden being one, the scanner is a separate thing.
And the scanner could deal with some other notification mechanism, but that's not the only case. And I'm done.
Thank you. And we do have a couple of people in the queue, and we're kind of tight on time, but the current queue, Warren, and then Ed, and then John, go ahead.
So Warren Kumari. When we originally wrote the CDS and CDNS key documents, we actually sort of floated this idea.
Yeah.
And at the time, we got fairly strong pushback because it was viewed as potentially sort of a DOS obfuscation thing, right? I could spoof queries towards the TLD servers saying that I'm some other zone, and that would then cause them to keep polling the child, asking for updated info. It's not really an amplifier, but it's like you can hide the source.
On the other hand, does this differ in any way from the ability to send a standard RFC 1996 notify SOA to a secondary? That would cause the secondary to poll the primary.
Yes, but I can, on my primary and secondary, I can say who I'm willing to accept notifies from.
Absolutely.
If I spoof them towards the TLD and the TLD does this, it'll keep poking the child. I don't think it's a major issue. I'm just listing some history.
I've heard the issue before, and I agree with it. And my view is that I don't think it's a major issue for the same reason as you say, but we can. Well, we've dealt with DDoS attacks before, and the answer is probably rate limiting, because I don't really see anyone having a need to send CDS notifications because they're rolling their keys 100 times a second. That's exactly, and if that's once every week, that's fine with me. The important thing is, and this is going back to scanning, the important thing is that I want the ability, and that goes back to what Wes said about we want CSync and CDS, etc., to work. When I update my keys, when I roll my keys, I would appreciate it if the parent actually did something now rather than 24 or 36 hours into the future. Because in Sweden, that's how long it takes to do a full scan. We cannot easily do it faster than on a 24-hour clock. And that's not fast enough when I want to roll my keys now.
Yeah. Let's see.
Hey,
Okay.
Ed Lewis.
Keep it quick, please.
Yeah,
Thank
okay.
you.
And to keep this quick, we know that event-driven is more elegant than polling. However, polling is simple, and as long as we can pull it off, that's our go-to usually. So I'm going to say here is that I read this. This sounds very developed or complex to do. I want to see polling fail before this is the preferred way to go. And what you just said, but you can't get it done in 24 hours. We can do things in parallel. But given a talk I heard where someone said, oh, polling's easy for this case, I really want to see polling fail before we really have to go this way. It's a great way to go, but it is more complexity in a different direction.
Go ahead.
Yeah, John Levine. I generally think this is a good idea because I wrote a draft that said more or less the same thing. However, sort of related to what Ed said, I mean, you have to poll. I mean, with the existing notify it pokes you to poll now, but with no notifies, the secondary still poll.
I agree with this.
Okay. And the other thing is the new RR type. I would take that out because I don't think it's useful. I mean, existing use of notify, the secondaries need to be hand configured to know where to send the request, because as often as not, there's a hidden master. It's not one of the public NSs, and the master needs to know which secondaries are to allow to send it updates to avoid random annoying stuff. So unless lacking a much more sophisticated way for both to explain to each other where they're going to go, I would just take out the new RR type, and if we later figure out there's some way to mechanically install both of these limitations about who notifies who and who you listen to, that would be fine. But the proposal here, I just don't think will work.
I appreciate that discussion, because that's the discussion I want to have. That said, in the original notify, the way that the master or the primary discovered the secondaries is by looking in the zone, typically.
You can do it explicitly, but typically it will look in the zone, it will find all the authoritative NS records, remove itself and send notifications to the others, which is very similar to this mechanism.
You can do that, but in reality, there's a lot of hand configuration.
Yeah.
Gentlemen, continue on the mailing list?
Sure.
Thank you very much.
I'm done.
Yeah, sorry, just we're at time. And we have one more.
Yeah, right there.
Schumann or Peter, which of you is? Peter is walking to the mic, so I guess it's his turn.
It's rare. I have to take the mic down. Okay, so very quickly. Over the last years, some discussions have repeatedly surfaced about how to do zones and delegations with multiple algorithms, algorithm rollover in the root zone and multi-signer stuff, and whether you have to have all the signatures for those algorithms. So let's quickly see what can be done in that space. The motivation is the current specs, which I'll not read out, just say if you advertise algorithms in the DS record set or trust anchor, you have to have DNS keys for each of those algorithms and also serve RR6 for each of those algorithms in all responses. That makes it difficult for some use cases. For example, for the root zone algorithm rollover, which will happen eventually. It's been mentioned before today that double signing has some risks, key management, complicated amplification, transport limitations, all of that. And an upcoming report by the rollover design team essentially found that it would be helpful to reduce the time frame in which you need to do double signing. So that would mean that you would announce and configure the new trust anchor with a new algorithm even before introducing the new signatures, but that's currently not allowed. And then for DNSSEC multi-signer setups, if you have several providers, they might not use the same algorithms, so they can't serve signatures of both algorithms, for example, 8 and 13, if you have that set up. But for example, Cloudflare would serve 13, I suppose, and then somebody else 8 perhaps. But you also can't do that currently because the signer is supposed to have all the signatures available in the response. You also need that if you do a provider change without turning off DNSSEC, where the two providers don't support the same algorithm, then in the transition phase, you will run into the same problem. And also, if you do online signing, multiple algorithms might be computationally intense. So do we really need to require presence of all signatures always, or can we find a way of relaxing this requirement? And if we do that, what's the implications? The simple approach would be to just drop the rule, say it's fine to just serve any one of those signatures. If you do that, which is straightforward, there are some implications that are not desirable, particularly when a resolver supports only one of the algorithms that are advertised and not both, or all three, or whatever the number is. If the resolver would receive a response with a signature that it doesn't understand, then it is supposed to, be suspicious about it. It doesn't have a valid path, so it's going to answer with serve fail. That puts the burden on the signer to make sure that doesn't happen. The signer in such a setup where you skip signatures only should use algorithms that are widely supported so that the signer can trust that the resolver will find a valid path. That's actually the reason why the current specs prescribe that you have to have all those signatures ready so you don't have to worry about that being the case or not. And for resolvers, it's difficult, for example, when a signer thinks that the algorithms they are serving, like 7 in a 7+13 setup, is widely supported, and then suddenly Red Hat turns off algorithm 7. And then what do? A Red Hat-based resolver wouldn't find a valid path anymore, so serve fail. And if you don't want that serve fail, you would have to relax the requirement on the validator too. So then you go insecure, but then you're susceptible to downgrade attacks, which is precisely what we don't want. So the existing requirements are actually well motivated, and it must not be possible to disable DNSSEC by adding an algorithm to the zone, pretty much. And another complication is if you add a future or a new incoming algorithm, like you have a 13 setup, you add 15, for example. If that would lead to downgrade, then of course that is not an option at all, because it's essentially would forbid adding a new algorithm, so you wouldn't have an upgrade path. So all of this isn't really very much feasible. If the rules are just dropped, it's going to be dangerous. But what else can be done? So here's a quick taxonomy. There's in an algorithm life 3 kind of phases. When the algorithm is new, it's in its youth, It's not yet universally supported by resolvers, so it's insufficient in a way because it doesn't suffice to have only this signature. There will be resolvers that don't understand it. Knowing this is important for signers. Then there is the golden years where the algorithm is universally supported. Essentially, if it's in the response, all resolvers will understand it, and it's kind of the golden years. There's only a negligible population of resolvers that doesn't support it. And then there are sunset years, when an algorithm that used to be sufficient is no longer supported universally, like today, algorithm 5 and 7. And in this case, it's possible that a signer still uses that, but some resolvers have dropped support. This could lead to the serve fail problem I mentioned earlier. And so that's a case perhaps that needs to be addressed in any proposal that is trying to find a solution here. But in any case, signers using such algorithms are advised to transition away from such sunset algorithms. So with this taxonomy, there is a proposal that I've been working on with Schumann and Victor, and Wayne was also in the conversation, a bunch of other people. And the proposal is actually as follows. So the idea is when a zone advertises at least one sufficient algorithm in its DS, record set, or trust anchors, then the signer may skip publishing RR6 for all other advertised algorithms, right? So as long as you serve one sufficient RR6, that's okay. If you don't advertise any sufficient universally adopted algorithms in the DS or trust anchors, then the old rule is in place and you must publish RR6 for all advertised algorithms. And for the resolvers, things essentially, it's as before, any valid path suffices. Now, as I said before, when an algorithm is phasing out, it's getting a little more complicated. So what to do if a formally sufficient algorithm is sunsetting? It might be that an outdated signer still publishes R6 in this case, and a resolver who dropped support for this one already doesn't, well, like 7, for example, and Red Hat, as I said before, won't find a valid path. Now, in such configurations where the signer is already supposed to move away from this algorithm and upgrade essentially to a new algorithm that is more widely supported, the signer shouldn't expect really that resolvers still support that because it is not universally supported anymore, and instead should prepare themselves for having their zone or response treated as insecure. So that's actually the only change in validation behavior. When there is 2 algorithms, let's say 7 and 13, one universally deployed, 13, and the other no longer universally supported, then it's fine for the resolver to accept the response as insecure or even treat the whole zone as insecure. Of course, the resolver still may validate responses which do have the signature of the supported one, but doesn't have to necessarily. Now, this only affects resolvers which actually have dropped support for one of these algorithms. If 7 and 13 are both supported at a given resolver, then of course there's no change, the zone is secure as before. Okay, exactly. All right, so what are the key benefits? So the benefits of this are the root zone transition can be done between sufficient algorithms like 8 and 13 without dual signing at the time when you introduce the new trust anchor. You can upgrade zones from insufficient algorithms to sufficient ones without disruption, without running into serve fails with resolvers that have already dropped support for one of the algorithms, if neither provider supports the other one. And in permanent multi-signer deployments, you can do that safely as long as both algorithms are universally deployed. For the resolver, implementation is actually pretty simple. The only thing that needs to be done is being aware of which algorithms are no longer sufficient, which you can keep in a static list of algorithm numbers. And it doesn't need to be implemented now. It only needs to be implemented once you actually disable an algorithm. So you can add that number to this insecure list when you're making a code change for that anyway. And yeah, otherwise the resolver doesn't need to specifically know anything about the use cases that are facilitated with this. We've talked to a bunch of resolver implementers with PowerDNS Recursor and KNOT resolver and Unbound and Matthijs from Bind. And they all said this is feasible to do if the working group thinks it's a good idea to have consensus on. So the question is if it is a good idea. The summary is, essentially, multiple sufficient algorithms can be used without dual signing. So it's kind of like single algorithms ESK rollovers. It makes it much simpler to do algorithm rollovers, multi-signer support, and switching operators. And the kind of cost for that is if you insist on using an insecure algorithm like 5 or 7, insecure in the new taxonomy where that's no longer widely supported, then the signer runs the risk of having the zone treated insecurely, but they can upgrade.
Okay.
That's the proposal.
So unfortunately, we are about to lose Meet Echo support because we've run a couple minutes over. Okay, go ahead.
Yeah, sorry, it was my mistake. They don't close the Meet Echo session without our agreement. So, indeed.
But yeah, so let's
really
close the queue, but we have a couple of folks. Quick comments, thank you.
very short comments, and we take it off the list.
Okay, it's Ed Lewis. So in short, this is a problem that needs to be solved. However, until now, DNSSEC, the DNSSEC security algorithm in use is just a number. We don't have metadata related to them in any of the code up to now. And this is what scares me. This is like Brave New World. This is a whole different way of looking at the use of the cryptography in DNSSEC. So I'm concerned about it. I have my doubts about this key, this algorithm ranking and all that. I'll just say that and leave it to the next person.
Thank you.
Sam Weiler. This seems like it's taking your signaling out of band for what's sufficient, what's deprecated. Rather than think about all the edge cases there, I have a question for you. What if you were to define a new algorithm number, say 83, that means 8 or 13? Ponder that one.
You said 83, that is what? I didn't hear that.
That means 8 or 13. That means either of your sufficient ones right now.
Well, you have to wait for that to be universally supported, but then I guess it's fine.
Ponder that in depth.
Well done.
Ben Schwartz. I think I want the opposite of this, because right now we have the thing that we have this problem where if you dual sign, your zone is as secure as the less secure of the resolver of the algorithms that you chose. And so I wrote a draft that everybody hated like several years ago called DNSX strict mode that was trying to reverse that, make your zone as secure as the most secure algorithm that you signed with. So that's the property that I still kind of think would be nice. And maybe there's a way that we can get all of these things here. One thing I could imagine is saying, starting now, any new algorithm numbers minted in the IANA registry carry with them some new semantics. Those semantics are immutable, so we're not going to like then change the behavior that later, like, oh, it was sufficient, but now it's old, so you have to go update your resolver code, and I don't know what happens with like resolvers that didn't get updated. But we might find a new state machine that can be introduced that way and gets us all of these things.
Yeah, thank you. I hear you. I think nothing's for eternity, so it's fine to phase out things. But you're certainly right that there is kind of this tension between weaker, stronger, and all of that. I think DNSSEC doesn't have a ranking really between algorithms. But yeah, let's see what the discussion will be like on the list. I really appreciate any input, and Shuman and Victor certainly do as well. And please send edge cases where this wouldn't work. I think this is the most important thing to sort out to see if this is feasible. Thank you.
Thank you, Peter. Thanks, everybody. We are a couple minutes over time, so we're done. Thanks, everybody online and in the room for joining us today, and we will see you next time.
So, well done. Yeah, sometimes it's difficult. Yeah. Especially the first one. Yeah. 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 And I know that some working groups at least 15 minutes. Yeah.
Thank you.